Welcome all of you to Annie Maths. This is my second video in exponents. Okay, in the first video we had talked about the rules in exponents and the chapter exponent. Now this is going to be my second video where we'll do some very elementary questions, okay, which must be done before we attempt the big questions. Now this is one mistake we always do. What is the mistake? We don't do the elementary questions and we try to do the very difficult questions from the end of the exercise. Okay, now that is not a very good idea because it will lead to a clear demotivation if you are trying to do so. So always do the very elementary ones, and you see there are certain things that we need to do in order to understand exponents clearly. Here in today's video we shall not be doing rules as such. We are not going to do rules as such. Okay, we are going to take up only few very basic questions. You'll see how we start to handle exponents. Okay, that is all. In our next video we shall be doing sums completely based on the rules that we have learnt in the first video. So this is going to be our second video on exponents. As I have always been telling you, please see the videos. If you really want to understand the topic, please see the video serially. I shall be numbering them as part 1, part 2, part 3, and I think I shall be requiring about 4 videos to complete this chapter completely. Okay, then let's see. Okay, then let us start. The first question is, write each of the following in power notation. Okay, when they tell us power notation, what do they mean by this? Okay, we'll be writing in power notation now. It simply means write in the exponential form. Okay, so 5 by 7, they have given us a question like this: into 5 by 7 into 5 by 7, okay, and into another 5 by 7. Okay, now we have to write this in the exponential form. Now here I want to tell all of you, whether we are doing decimals, exponents with decimals, or we are working with fraction and exponents, or it's a regular number and exponents, remember it is the same. The rules that apply are always the same to all three of them, or even if it is algebraic. Okay, so even then the rules are the same, so you don't have to learn it separately for any one of them. The rules are always the same. So let us see how we write this in the exponential form. That is 5 by 7 to the power 4. That is it. We don't, since they told in the exponential form, it should have a base and a power. Okay, now let's take a negative one, which is, let's take minus 1 by 6 into minus 1 by 6 and again into minus 1 by 6. Now don't ever miss the bracket. I repeat, so it is minus 1 by 6 to the power 3. Okay, minus 1 by 6 to the power 3. Now do not, if you are supposing you are not putting the bracket, okay, let me erase the bracket, and by mistake you just write it like this and you write the 3 here. You know what it means? It means that the power 3 is meant only for the 1. Okay, here when we put the brackets, remember the power 3 is meant for the 1, it is meant for the 6, and it is also meant for the minus sign. So there's a big difference between a sum when the minus sign is inside the bracket and when the minus sign is outside. Okay, so here if you have the minus, then the minus is also getting repeated 3 times. But if you have the minus outside, then the minus is not repeated 3 times. It remains once, and the rest of the number inside the bracket gets repeated thrice. Okay, so the bracket is absolutely important, even if there is no negative, because bracket is meant for 2 things. One is to ensure that the minus is inside it, another is that it is meant for the numerator and the denominator, as I said. Okay, now we'll take up another question. Here it was quite obvious, but let us take us another question where again it will be power notation only, but then you see the number is given as a 1 fraction. Okay, like it is 25 by 36. If it is 25 by 36, then what do we do? it is clearly 5 square and a sorry and a 6 square, right? It's a 5 square and a 6 square. Okay, that makes it 5 by 6 square, isn't it? So this is a power notation for this fraction. Let me take another one which will be a negative one. Okay, now we shall be taking a negative a fraction, and then we'll be writing it as a power notation. So let us see. Now the number that I was talking about is minus 27 by 64. Okay, it is negative, there's a fraction. Now here I will take minus, I'll just stop thinking about the minus for some time, and I'll take the minus, I'll just copy down the minus and I'll write a 3 cube. For 64 I'll write a 4 cube. Now you might be wondering how I wrote the 4 cube. If you, I know it. I know 64 is 4 cube. That's why I wrote. But you think you are not being able to write, then do prime factorization and write it. So here it is 232 and then 2 and a 16 and a 2 and an 8 and a 2 and a 4 and a 2 and a 2. Okay. So here I have got 6 2's. Now you might be thinking that why didn't I take 2 to the power 6? Why did I take 4 to the power 2 only? Okay, why did I take 4 to the power 2 and I didn't take 2 to the power 6? Now I could have taken 2 to the power 6, but then I didn't take, because if I take 2 to the power 6, then my power will not match with the numerator. I want to get it as one single exponent, that is the entire fraction will have one power, and hence I will not take 2 to 3 to the power 3 here and 4 to the power 3 here. Okay, I will have to take, I'll not take 2 to the power 6 here. I will have to take some number which has a power 3. Now my next step is take the minus inside the bracket and put the cube outside. Now how did I so simply take the minus and put the cube outside? Here I want to tell all of you. This minus, this cube which is outside is, and the bracket is meant for two reasons. Firstly, I put the bracket so that I can tell you that this 3 is meant, this cube is meant for the 3 in the numerator and also meant for the 4 in the denominator. And also the minus, the 3, the power 3 is meant for all three things, hence it is kept outside the bracket. Okay. Another thing, how did I so easily put the minus inside? Now note one thing, if I have a negative, okay, negative means minus, this is minus is going 3 times, isn't it? Minus is also repeated 3 times. So it is minus into minus into minus. 3 times when you get minus, okay, minus into minus and into minus. 2 of them make a plus and then one negative. This positive and this negative again makes a negative. So whenever the negative sign is repeated, multiplied repeatedly for 3 times or an odd number of times, the final answer is always negative. Hence here I will get a negative answer. Okay, therefore I can, even if I cube it, I can get back to this. So this is equal to this, hence this is equal to this. Okay, the case is not going to be the same if I have an even power. Now here I want to tell you one thing. My final answer, anyways, let me finish this sum first. My final answer is therefore minus 3 by 4 to the power 3. The sum is going to change a little if I have a even number here. Now let us see. Now let me see if it is a negative sign, what happens. Okay, let me take this sign, this sum, minus 1 by 64. Okay, here I clearly know that it is minus and then 1 and this is 2 to the power 6. Okay, now I have to write this in power notation. Okay, so what do I have to do? If they give you this in power notation, then what you have to do is you have to write this and this. Now look carefully, this. I got my 1 by 2 to the power 6 and the minus comes here. Let me first talk about the 1. Why I could write the 1 on the 6 on top? Because 1, this 1 repeated 1 into 1 into 1 like that. If you go 6 times, you will get a 1 only. That is why we can write the 6 over here. Okay, and this is 2 to the power 6. Okay, and this is 2 to the power 6. What happened to the minus? This time I could not put the minus sign inside. I could not put the minus sign inside because had I put it inside, if this was an even power, it would have made the minus into plus. So my entire answer, my power notation here with the minus inside would have become 1 by 64 and not minus 1 by 64. Therefore, if I have to write this in power notation, I will always have to put the minus inside, minus outside, sorry, not inside. Okay, so this is what I have to be absolutely careful of. Okay. Now let us see some other questions where we shall be writing, that is, we'll go opposite. We'll go from power notation exponential form to, we'll go to rational numbers. That is just a plain fraction. Okay, so let us see. Let us take one sum where we'll now go from, we'll form into a rational number. Okay, we'll form the given exponent to a rational number. How do we form it to a rational number? Let's see. Let us take one exponential number like this, minus 8 by 3 to the power 3. Let's take this. Okay, we have to convert this to a rational number. Rational number means basically in the form p by q, where p is an integer, q is also an integer, and q is not equal to 0. That is what the definition of rational number says, and you have done it. So, minus. Here, first thing, let's talk about the minus. The minus is getting repeated thrice. Minus is getting repeated thrice. So, the minus remains. 8 into 8 is a, 8 into 8 is how much? Is a 64. 64 into 8 again. Okay. That is how much? Okay. 48 and 3. 512. 512. That is 8 cube. And if I take 3 cube, that is a 27. Okay. So my final rational number is minus 512 by 27. You have to be very careful. People get this part correct, but this part goes wrong. The negative part goes wrong. Let me now take one sum where you have an even power and a negative fraction. Okay, like you have minus 3 by 2 and then you have to the power 4. Even power, negative fraction. What do we do? Okay, so even power, the moment we see an even power, the minus disappears because it becomes positive. You can write a plus if you want to. If you don't want to write even, that is correct. 3 to the power 4. Okay, let me write it only like this. 3 to the power 4 is 3 into 3 is a 9, and if you multiply it 4 times, 9 into 3 is a 27, 27 into 3 is an 81, write the 81 here. 2 4 times, 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. Here goes the 16. So my final answer, you see, the minus sign disappears. Okay, so this is how we have converted it to a rational number. Now one very cute looking sum is minus 1 to the power 0, and that is 0. Okay, minus 1 to the power 0. Any number, I have told you in the rules of exponents, any number to the power 0 is always a 1. So be it algebraic, be it decimal, be it fractional, be it a regular whole number, integer, anything. Let us now talk about, we'll now talk about a negative power. Okay. So if they have given us an exponent which is 4 to the power minus 1. Okay. And then they wanted us to write it as a rational number. Before this it was a fraction, and now it's a, but all the powers were positive. Now the powers are negative. What to do about this? Now I had told you in my rules, in the exponent rules, if a number is coming from the numerator, you want to write it, you want to write it in the denominator, the sign of the power changes. If it is going from numerator to denominator, the sign changes. If you are going from denominator to numerator, even then the sign changes. So now, if you want to write this, this is 1 by 4 you make it and it becomes to the power 1. That is it. So you don't have to write the 1. Okay. So that is the usefulness of, this numerator denominator change. You can change the sign of the power as you wish. So we have converted it, you can see clearly, to a rational number. Now if you see the next one, if you see, this is where we need to start thinking. Of course, we know the rules by now. Here, the moment children see this sum, they will take this minus and they'll take this minus. They will multiply because minus into minus is a plus. Now, that is not the case. Let me tell you very clearly. This minus is meant for making the number numerator denominator change. This number is coming from the number line. Okay, so it is a negative integer. So it has nothing to do. This minus and this sign, these two signs are never meant for any calculation. You are not supposed to work with these two signs even if you are tempted to do so. Okay. So here I have a minus which I have to leave it alone like this. Whether you take it in the numerator or denominator, this minus 6 remains. And so simple because of this, when I change it, you can write the minus here with the numerator, no problem. Okay, you want to write it here, that is also okay. So I have removed the minus sign by doing this, by keeping it in the denominator. Now let me take another question which is a fractional one with a negative power. Now see, fractional one with a negative power. And this is definitely not a rational number. I have to convert this to a rational number. Okay, this is a rational number. Okay, this also is a rational number, but this isn't a rational number. Now, if I have to remove the minus sign, what I have to do? I have to give the inside a turn. Inside material has to be given a turn. Make it 3. 3 by 1 you don't require. Only 3 is enough. And that is enough because this is now 3 to the power 1. And here you get 1 to the power 1 which you don't write. Okay. Then, let's take another one. Now see how these sums are, each sum is slightly different. This one has to be converted to a rational number. Again the same temptation. Shall I multiply this? No, you will not multiply that. Okay. So you will just write the minus. You will give the number a turn, that is 3 by 2, and it becomes to the power 1. Okay, so this is your rational number. Now, if you are wondering why this happened, let me split this and tell you why it happened. See, instead of writing this, okay, let me make it somewhat this way. Okay, this is the answer definitely, but let me make it like this. Let me split it. 2 to the power minus 1 and 3 to the power minus 1. This is a sum, right? Now, I want to remove the minus. So, see, take the 3 up, minus gone, take the 2 down, minus gone, and this minus comes back here. Have I not got the same answer? So, if you want to remove the minus sign, give the inside a reciprocal and your minus sign is gone. In other words, if this sign is positive and you want to make it negative, then also give it a reciprocal and you can change the sign of the power. Okay, so this is how you can convert a power notation number to a rational number, okay, by removing the power. Now here if you have a minus 2 or minus 3, that is fine. You can, here it is 1, so it is not showing here, but if it is a minus 2 here, you just write a plain 2 here. Okay, you write a positive 2. Then let's come to something which is slightly different. Let's see. What we are going to do now is find the reciprocal of the number 3 by 8, okay, to the power 4. 3 by 8 to the power 4. Find the reciprocal of this number they are saying. Okay, reciprocal. How do we find this? Reciprocal of this number. Now, if we are going to find a reciprocal, remember one thing. What is the reciprocal of 1 by 3. If supposing I take, what is the reciprocal of 5 by 6? It is 6 by 5. Now another thing, I have seen very good number of children writing like this: 5 by 6 reciprocal is equal to 6 by 5. Okay, this is a big mistake. Never use the equal to sign when you are writing reciprocal. Don't use the equal to sign. You can use an arrow like this. Okay, because 5 by 6, do you think is ever going to be equal to 6 by 5? Then why put the equal to sign? Equal to sign has to be used wisely. Okay, so now we are going to find the reciprocal of this. Why I am telling you here, because here also I don't want equal to signs. Okay, so 3 by 8 to the power 4. If it is 3 by 8 to the power 4, what do I do? How do I get the reciprocal? Okay, so all I have to do is 8 by 3 to the power 4. They didn't tell us, see, I also used an equal to arrow. Okay, they didn't tell us to convert the number to negative power or anything like that. They have only told us, or to rational number, they didn't even tell that. They only said convert it to reciprocal, and I did it. Now if you think how it happened, let me split this and work in steps. 3 to the power 4, 8 to the power 4. Okay, if I want to write reciprocal of this, then it is 8 to the power 4, 3 to the power 4, and that is equal to 8 by 3 to the power 4. Yeah, okay, so 8 by 3 to the power 4, so that is the reciprocal. So if they are asking for the reciprocal, do not change the sign. Now this is a very common mistake, the moment an exponent they ask reciprocal, and till here is fine, but if they give a negative power and all, there's a complete confusion as to how to solve it. So if you think about it, even in the examination, you can split it in rough and check like this. Then you will never get a mistake. Okay, so I have split this and I've shown you how straight away I did this. So in reciprocal, you don't change the sign of the exponent ever. You don't change the sign of the exponent. All you do is give this a turn. Okay, you have to just give this a turn. That is all. Okay. Now let me take one more sum where they are asking for a reciprocal. Let's take minus 5 by 6 to the power, okay, 11. Now again confusion. Why minus? What to do with the minus? This power is odd. Shall I keep it? Shall I not keep it? Okay, shall I keep it outside the bracket? So many things. All you have to do here, as I said, don't change the sign of the power in reciprocal. So write the power as it is, minus sign as it is, fill up the rest upside down. That's all. Okay, so this is then 11. Okay, so you have to, so this is minus 6 by 5. That is all. You can split it and check. I am getting 5 to the power 11, 6 to the power 11. Here I am getting, again see, I have used an equal to sign. No, arrow. Yeah, it is such a bad practice. Okay, so you have to put an arrow, never put an equal to sign. So here this is minus 6 by 11, 5 by 11. Okay, so sign of power is not changed in reciprocal. Okay, but then if you are writing it like in the previous question, you are writing it as a rational number, then you can change the, you can turn what is inside and also change the sign. Okay, so that is how it works. Then try to remember these when you do your sums. Now we'll come to something very simple, but then very often people get this wrong. Let's see what it is. So our next sum goes somewhat like this. See, 4 to the power 0 plus 5 to the power 0. And the immediate answer is equal to 0, 50% of the class. Okay, this is wrong. Why it is wrong? Okay, 4 to the power 0 is a 1. I have told you any number to the power 0 is a 1. 5 to the power 0 is also a 1. Okay, answer is a 2. That is why they'll ask you in MCQ, It's a small question they'll ask in MCQ or in 1 markers. Now another question, 6 to the power 0 into 7 to the power 0. This is again 1 for 6 to the power 0, 1 for 7 to the power 0, and then what do you get? You get final answer as a 1. Okay, so I think these were the basic rules of solving an exponent. Our next video we are going to take up questions which are going to be little more tough than this. There we'll start using the rules properly in sums. Okay, so the questions will also be bigger. Here I taught you how to attempt the questions. Okay, so in the next video you will see how we'll be using all the 4 or 5 rules in bigger sums. You'll get all the links of all the parts of the videos of exponents in the description box. Okay, so you can click there and go to the other videos of exponents. As I said, always go part 1 to part 4, not randomly. Okay, then that's it for today. If you have liked the video, do not forget to like, share and subscribe. Thanks all of you for watching. Bye all of you.